here is what I am going to do. I have a green curve, f of x. I would like to find the slope of the green curve at the purple point using this tangent line. What is tangent line? Tangent line is a straight line that touches the graph of a function at one point, exactly one point. So I have a straight line touching this purple point exactly one time. That means the slope of this tangent line is equal to the slope of the green curve at this point. Let me say this again. I have a green curve. I would like to find the slope of the green curve at this purple point using this tangent line. This tangent line is a straight line that touches the graph one time at this point. The slope of the tangent line is equal to the slope of the green curve at this point only. At this point only, not at any other point, at this point. However, that creates another problem. I only have one point. So if you recall the slope formula for linear function, the y2 minus y1 divided by x2 minus x1, that requires four number, right? So imagine this, you have 2 points. How about this? The basic ingredient to sketch a straight line is having 2 points. So you have 2 points, you have a straight line, right? If you only have 1 point, that is not enough. So if you only have 1 point, that is not enough to create a straight line. So I only have 1 point right now. I cannot use that formula to find the slope. So therefore, I have to draw a secant line. A secant line is a straight line right here, a straight line joining 2 points on the graph of a function. All right. So I am going to sketch a secant line joining 2 points, one at the purple and then one right over there. Okay, and then what is the coordinate of the purple point? So this one, let's say this is x and then this is f of x, right? So the purple point, the coordinate is x comma f of x. F of x means you plug in x to the function, you get your y value. And then from the purple to the blue, do we agree that we have to make a few steps to the right? So from this x mark to this x mark, I am going to call the step delta x. So this will be x plus delta x. Or sometimes some textbook, they just let the delta x equals to h. Some textbook use h, some textbook use delta x. If you are not comfortable with that, you can just use x. So this one, let's label this. So this is called delta x. Delta x means change of x. So from this point to this point, the run is x plus delta x, and then you have to go a few units up. Then what is the coordinate of this point? This coordinate is x is equals to x plus delta x, and then to get the y value, you have to plug in the x coordinate to the function. So this will be x plus delta x. You plug it in to the function because this point is on the green curve. So now I have 2 points. This is the first point, and then this is the second point. So do you see that? So right over here on the right hand side, I drew the straight line again, and then this is a run, this is a rise, and then the first point is x comma f of x, and then the other point is x plus h comma f of x plus h. Let me say this again. Some textbook use x, some textbook use delta x, some textbook use h. I will just use h because having one h looks so much cleaner. So let's use h from now. So now we have 2 points. Can I use the straight line formula? Of course. So the slope is equals to y2 minus y1 divided by x2 minus x1. So we have y2 minus y1 and then divided by x2 minus x1. So if you look at the denominator, the x and the minus x got cancelled, right? So overall, you have x plus h minus f of x divided by h. Now, let's take a look at the line again. We have a tangent line in red. We have a secant line in blue. They are two different lines. They do not have the same slope, right? The slope of the tangent line is not equal to the slope of the secant line. Right? That's correct, right? So how do you make them equal? How do you make the tangent secant line becomes the tangent line? So that means I have a secant line, right? So this one gives me a slope. But this slope is not the slope of the tangent line. How do you make this becomes the slope of the tangent line? So to do so, what you have to do is you have to minimize h. So you have to minimize So next step is minimize H. So minimize H, that means you want to do this. You have to picture this in your mind. So use your finger. Put your finger on this point, the X plus delta X. Put your finger right over there. And then you move this point to the purple point along the graph. All right, so this is where your finger is, and then you start the moving. So from here, and then moving along, and then start right over here. Do we agree that once you reach to the purple point, the secant line becomes a tangent line? That is a yes, right? Let's do this again. Put your finger right over here, and then move to the purple point along the green curve. Once you reach to the green curve, the secant line becomes a tangent line. So let me draw another one for you. So this one, if you can get closer, so how close? So let's say let's don't take that point. Let's take this point. So this point is closer than the first picture, right? So now the secant line looks like this. It is hard to draw this kind of picture. So let me just do this. All right. So now it's closer, right? So we are trying to minimize H. H is delta X. So you are trying to shrink X. You are trying to push this point to this point. So this is just getting closer. So once the purple point, once the blue point reaches to the purple point, the secant line becomes a tangent line. So minimize H. How do you use limit to write minimize H? So this is how we do it. So let me do this in a different color. So the way we do this is we write limit as H approaches to 0, and then the top, no change. The top is f of x plus h minus f of x, and then the bottom, so since you get rid of these two x, then you have a h right over here. And some textbook, instead of having h goes to 0, they have delta x goes to 0. And then let me write both for you, because I still have some space. So for some textbook, they will just do limit as delta x goes to 0, and then they draw a fraction bar. So this is delta x, and then this is f of x plus delta x, and then minus f of x. So what is this called? This is called the limit definition of derivative. So this is the limit definition of derivative. Now, do you see that there is a keyword derivative? So what is derivative? Derivative means slope. So let me use a color that I haven't used. So this means slope. What is the derivative of a function? That means I'm looking for slope. Every time someone mentions the word derivative, you are thinking slope. Okay, so that is the limit definition of derivative, and that is also the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you're on your way out. I will show you more examples in the next video. See you there.